Hey there, science fans. Have you ever noticed how your phone or laptop gets warm when you've been using it for a while? That's because all those tiny electronic components inside generate heat as they work, and just like we don't want to overheat, our gadgets need a way to stay cool too. That's where thermal interface materials, or TIMs for short, come in. TIMs are like special materials that we put between the electronic components and the heat sinks. You know, those metal plates with fins that help dissipate heat. They act as a bridge to carry the heat away from those hard-working components and keep everything running smoothly. Think of them like the unsung heroes of the electronics world, working behind the scenes to prevent overheating and keep your devices functioning at their best. Without TIMs, our gadgets would overheat and malfunction, and nobody wants that. From our smartphones and laptops to powerful computers and electric cars, TIMs play a crucial role in keeping our electronic devices running cool and reliably. So you might be wondering why we even need TIMs in the first place. Can't heat just travel from the components to the heatsink directly? Well, not so fast. You see, even surfaces that look smooth to our eyes have microscopic imperfections and air gaps. These tiny imperfections create resistance to heat flow, making it harder for the heat to escape. That's where our trusty TIMs come to the rescue. They fill in those tiny gaps and create a smooth, continuous pathway for the heat to travel from the component to the heatsink. Imagine spreading butter on a piece of toast. The butter fills in all the nooks and crannies, creating a smooth surface. By improving the thermal contact between the component and the heatsink, TIMs help to dissipate heat more efficiently. This prevents the components from overheating and ensures they operate within their safe operating temperatures. Just like we sweat to cool down when we get hot, TIMs help our gadgets stay cool under pressure. Now that we know how important TIMs are, let's take a closer look at the different types available. Just like there are different tools for different jobs, there are different TIMs suited for various applications. First up, we have thermal greases. These are like thick pastes that are easy to apply and fill in those microscopic gaps effectively. Then there are thermal gels, which are similar to greases but have a slightly more viscous consistency. Thermal pads are pre-cut sheets of thermally conductive material that are great for applications where precise thickness is required. For applications that require even better thermal performance, we have phase change materials. These cool materials change their state from solid to liquid at a specific temperature, absorbing a large amount of heat in the process. And finally, for the most demanding applications, we have metallic TIMs. These TIMs are made from metals like silver or copper, which are excellent conductors of heat. With so many different types of TIMs to choose from, how do we know which one is right for a particular application? Well, there are a few key factors to consider. One of the most important factors is thermal conductivity, which measures how well a material conducts heat. A higher thermal conductivity means the TIM can transfer heat more effectively. Another important factor is ease of application. Some TIMs are easier to apply than others, which can be a crucial consideration in manufacturing processes. We also need to think about reliability and resistance to environmental factors like temperature extremes and humidity. And of course, cost is always a consideration, especially in high-volume manufacturing. By carefully considering these factors, engineers can select the best TIM for their specific needs and ensure optimal performance and reliability for their electronic devices.